We often gaze into the night sky, marveling at the vast expanse of stars and galaxies. But what if I told you that this cosmic ocean is growing wider every second? Yes, indeed, the very fabric of space is stretching, making the universe a larger place with each passing moment. Well, it turns out the universe is indeed expanding. But how do we know this? The concept of an expanding universe is not as complicated as it sounds. Think of it this way. Imagine you're blowing up a balloon. As you fill it with air, the surface of the balloon expands. Now, if you drew a bunch of dots on the balloon before you started blowing it up, as the balloon expands, the dots would move further and further apart from each other. This is a simple analogy for how the universe is expanding. In the real universe, these dots represent galaxies. Just like the dots on the balloon, galaxies are moving away from each other. But here's the interesting part. It's not that the galaxies are moving through space, rather it's the space itself that's expanding. This concept was first proposed by Georges Lemaitre, a Belgian physicist and Roman Catholic priest back in the 1920s, and was later supported by Edwin Hubble's observations. Hubble observed that light from distant galaxies was shifted to the red end of the spectrum. This is known as redshift, and it's similar to the Doppler effect you experience when a siren moves past you and the pitch seems to change. This redshift suggested that galaxies were moving away from us. More importantly, Hubble found that the further a galaxy was, the faster it was moving away. This relationship, now known as Hubble's law, was a monumental discovery. It suggested that the universe was not static but expanding. Now, you might be wondering if everything is moving away from everything else. Does that mean we're at the center of the universe? The answer is no. No matter where you are in the universe, it would appear that everything is moving away from you. And here's another mind-blowing fact. Not only is the universe expanding, but the rate of this expansion is also accelerating. That's right. The universe is not just growing, it's growing faster and faster every second. So, the universe is not only expanding, but the expansion is accelerating. But what's causing this? The force driving the universe's expansion is something we can't see, touch, or taste. It's called dark energy. Imagine a tug-of-war. On one end is gravity, the force that pulls everything towards everything else. It's the reason an apple falls from a tree and why we stay grounded on Earth instead of floating off into space. Gravity is what keeps our universe together, holding galaxies, stars, planets, and all matter in place. On the other end of our cosmic tug-of-war, we have dark energy, a force so mysterious we've only known about it for a few decades. Unlike gravity, which pulls things together, dark energy does the opposite. It pushes things apart. This isn't just a theoretical concept. Scientists have observed galaxies moving away from each other at speeds that are not only fast, but accelerating. This was a shocking discovery, contradicting the previously held belief that the universe's expansion was slowing down due to gravity. So, how does dark energy achieve this? It's thought to be a property of space itself. As space expands, new space is created, and with each new bit of space, more dark energy is produced. This continuous creation of dark energy fuels the expansion of the universe, causing galaxies to drift further and further apart. But it's not just a gentle drift. The force of dark energy is so strong that it overpowers gravity, causing the universe to expand at an accelerating rate. This is why we say that the universe isn't just expanding, it's accelerating. Despite our understanding of its effects, dark energy remains a mystery. We don't know what it is, where it comes from, or why it exists. Yet it's thought to make up around 70% of the universe. That's a significant portion of the cosmos that we know very little about. Dark energy is a mysterious force, and there's still much we don't know about it. But one thing is clear: it's causing the universe to expand at an accelerating rate. The fact that the universe is expanding has some fascinating implications. For starters, let's think about our neighboring galaxies. As the universe continues to stretch, these galaxies, once within our purview, could eventually move beyond our observable universe. It's like they're on a cosmic treadmill, constantly moving away from us even as we try to keep up. This expansion could also affect the ultimate fate of the universe. Two prominent theories, the Big Freeze and the Big Rip, paint quite dramatic pictures. The Big Freeze suggests that as the universe expands, it will cool down. Over trillions of years, stars will burn out, galaxies will fade, and all matter will eventually decay, leaving a universe filled with nothing but a cold, dark void. On the other hand, the Big Rip theory suggests a more violent end. If the rate of expansion continues to accelerate, it could eventually overcome the forces that hold everything together. Galaxies, stars, even atoms could be torn apart, resulting in a universe that quite literally rips itself to pieces. These are, of course, just theories. The truth is, we're still trying to fully comprehend the vast complexities of our universe. We're like cosmic detectives, piecing together clues to understand the grandest of mysteries. Our understanding of the universe and its expansion is still evolving, but it's clear that we live in a dynamic, ever-changing cosmos. So, we've explored the idea of an expanding universe, the role of dark energy, and the implications of this expansion. We've delved into the profound concept that our universe is not static, but rather a dynamic, ever-changing entity that continues to grow and evolve over time. We've touched upon the mysterious dark energy, this unseen force that is driving the universe's expansion. It's a reminder of the enigmatic aspects of our universe that we are yet to fully understand. And we've also discussed the implications of this expansion, how it affects our perception of the cosmos, the future of galaxies, and the ultimate fate of the universe itself. But one thing is clear: our journey of discovery is far from over. There's still so much to learn, so many questions to answer. The universe keeps expanding, and so does our understanding of it. So keep asking questions, keep exploring, and who knows what we'll discover next.